When we look up at night, we're seeing stars that are several light years away, hundreds of light years away. So traveling to one of those, I mean, it would take years traveling at the speed of light. We can't even get anywhere near that. So we are kind of, in a sense, trapped in our own little neighborhood here.
For the Museum of Science in Boston, this is Pulsar, a podcast where we search for answers to the most fantastic questions we've ever received from visitors. Extremes tend to be popular when we ask for questions in our virtual programs, the largest shark, the oldest crater, and today's question is no different. What's the fastest thing in the universe? Joining me to chat about how fast things are is Caity from our very own Charles Hayden Planetarium.
Hi, thanks for having me. So the fastest thing in the universe is light.
Light.
Yes.
So not an actual object, just light is super fast.
Correct.
How fast is it?
It is about 186,000 miles per second. So if you want to think about that in a little bit more relatable terms, if you could travel at the speed of light, you could travel around the Earth 7.5 times in a second.
That's super fast. So light is the fastest thing. Nothing can go faster than that. It's kind of like the speed limit of the universe.
Exactly. Yeah. To get any object that has mass moving at the speed of light would require an infinite amount of energy.
So the things that we've sent other places in the universe, our spaceships, stuff like that, is not like close to the speed of light, but we can't go any faster. It's just nowhere close.
Exactly. Yeah. The farthest spacecraft that humans have ever sent out into space, Voyager 1, is something like 20 light hours away from us, and it's been traveling for over 40 years at like 10 miles per second, so it's not that far in the grand scheme of things.
So not like 1% of the speed of light with our spaceships, more like 0.001%.
Exactly, yeah.
So you mentioned you need an infinite amount of energy to get mass to go the speed of light, but there are things out there that have a huge amount of energy, like the middle of a galaxy, and that stuff can launch objects that are bigger than a small particle, pretty close to the speed of light, right?
Yeah, absolutely. So material that is moving around a black hole or falling into a black hole is accelerated to very close to the speed of light, but not quite all the way there. If any object has mass, it can never quite get to the speed of light, but it can get pretty close from, as you said, high energy events like black holes accreting material or stars exploding and supernovas and things like that.
So way more energy than we've like ever consumed on the Earth every second blasted out of the middle of these extreme locations in the universe can get stuff to move pretty fast. Like that's 99.9% of the speed of light.
Oh, yeah. Yeah, for sure.
This is kind of a problem for humans in a lot of different ways, that nothing can go faster than the speed of light. On the planet Earth, it's not really a problem because you're talking to someone on the other side of the Earth through the internet. The information travels at the speed of light. Your lag is like almost non-existent. Like if you're standing across a room from someone who's talking to Australia on the phone, the person in Australia hears the voice before the person on the other side of the room because light is that much faster than sound. But when you're talking about communication across distances in space, then we start to run into issues, right?
Yeah, absolutely.
And when we sent people to the moon, the light speed to get there is like a couple seconds. So it wasn't really that big of a deal. If we want to go to Mars, it depends on where Earth and Mars are, but the light signal delay there can be like over an hour.
Yeah, it would take, for communications between the Earth and Mars, it depends on where they are in their orbits, but yeah, it can take a significant amount of time. So in a way, if we ever sent humans to Mars, they would be fairly isolated since they can't quite have that almost instantaneous communication as like the astronauts on the International Space Station.
And our robots that are on Mars are already experiencing this. I mean, we can't give them instructions instantly. We don't get their data instantly. It can take minutes or over an hour. We have to make them autonomous. So the robots have to have those algorithms planned out when they go to drill something, when they go to fly the helicopter on Mars. It has to do that by itself.
Exactly. Even the landing of a lot of those rovers like Perseverance and Curiosity, all of that had to be pre-programmed, so they were just kind of on their own and everybody was crossing their fingers back on Earth.
Yeah, the 7 minutes of terror
Exactly.
to get from space to the ground on Mars happens, and then it takes like an hour for the data to get back, And then we don't know for that hour it's either there or it's not. And then we have to like watch it in real time. And so you watch the NASA control room. They're watching the data come in on an hour delay because of the speed of light. And you feel like you're watching it live, but you know that you're kind of like watching it recorded. It's like watching a baseball game the next day. You're watching it in real time, but it happened a long time ago.
Yep, exactly.
And then it's especially true of stuff we send really far out in the solar system, like the Pluto mission, New Horizons.
Yeah.
Pluto's like multiple light hours away. So that's really like something happens there and the spaceship's on its own, but that was a flyby. And so if something went wrong, we'd find out after it's thousands of miles past Pluto, nothing we can do. So that was really any time anything happens anywhere in the solar system, it's nerve-wracking because it has to go right the first time.
Yeah, exactly. It can be really scary to just be in the dark, but it's also really cool that we can communicate with distances that are that far, even though it takes a bit longer.
Yeah, so the furthest thing we're communicating with now is Voyager 1, you mentioned that. And it's still going after, 44 years now?
44 years,
and
yeah.
And so it's still, I mean, it records this data on 8-track tapes. That's my favorite fact about that one. It's launched in the 70s, and so that was the technology. But, you know, it's measuring out past the limits of the solar system, sending the data back, and then 18 hours later, we get it, and we pick it up. That's the limit of where we've been. And then kind of a bummer that, humans can't really go explore like a lot of the science fiction around the galaxy with even the speed of light. Even if we could go the speed of light, it would take 4 years to get to the next closest star.
Yeah. And one of my most kind of mind-blowing facts that I love to tell people is that if we wanted to send Voyager 1 to that nearest star that's 4 light years away, if it was heading in that correct direction, it would take another 70,000 years for it to actually get there.
So that's not like, you get on a spaceship with a whole bunch of people and then your grandkids will eventually see the next star. You're talking 70,000 years. Who knows what will happen on a spaceship in 70,000 years without being able to go outside or stop for gas or anything. It's mind-boggling. We're limited to that in our current technology. And even if we could make light-speed spaceships, it would take years to get to another star. And then the galaxy, full of stars, it's like 100,000 light years across. And so even at the speed of light, it would take so long to go anywhere. If we found another interesting place out there that we wanted to visit, even with robots that we could send really fast because they don't have pale, squishy bodies and we don't have to worry about the acceleration, it would take forever.
Yeah, we'll really never be able to see our galaxy from the outside. We'll never get a galactic selfie.
Unless we could break the speed of light barrier.
True.
Do you think we'll ever be able to do that?
Oh gosh, I don't know. Probably not, but who knows? Maybe someday.
Well, that's what we'll talk about next week. What if we could find a way to break the light speed barrier and send messages or people around the universe 1,000,000 times faster than light? Join us for part 2 next week when we'll hear from an award-winning science fiction author who has imagined worlds where light isn't the fastest thing. Until then, keep asking questions.